Subject of today's tutorial is the radicalic polymerization. As a substrate, we have this molecule with two styrene moieties. And for starting this radicalic process, we need a starter radical. We can generate a starter radical, for instance, by heating up dibenzoyl peroxide. We will have a radical of some kind. Let's abbreviate it with R dot. And this radical will react with one of the two styrene moieties. But only with one of the moieties, because we have the R radical always in low concentration. The radical now is always located at a position where it is very well stabilized, here in benzylic position, stabilized by mesomeric interaction with a phenyl group. If we now have a low concentration, if we work under diluted conditions, then the intramolecular reaction will preferably occur, and this means that the radical center will interact with the terminal double bond. This is a cyclization reaction, and it is, according to Baldwin, a 6-endo-trig cyclization. So, a 6-membered ring is formed, and we should draw a 6-membered ring. The phenyl group will be located here, the radical center there, and just for the orientation I draw these two hydrogens. Then this radical might again react with the starting material. So let's call it A plus molecule A. That means that we have the first 6-membered ring, and here now the second 6-membered ring. And the polymerization goes on. If we take into consideration that a 6-membered ring almost always prefers the chair conformation, then we can assume that in general the long-chained R group will occupy the equatorial position, whereas the phenyl group should be regarded as smaller, would end up in the axial position. Omitting stereochemical information, I can now draw the second phenyl group also in an axial position, and the elongation of the chain we will keep in equatorial position. Let's stop here. The chain goes on and on. Thanks for listening.